Okay, so let's make our first script. I'm going to open up a terminal window here, and in my home directory, I'm going to make a new directory called scripts, which will hold all of our scripts. Of course, there's nothing in there now. Let's go ahead and work on our first script. What shall we call it? Let's call it first script.sh. Now, .sh usually designates a shell script, and so that tells someone by inspection that something is actually a script that's going to be executable. And of course, we can name it whatever we want to. I just chose to call it this. I'm using the nano editor. Every script will begin with this symbol that's made of two different characters, the pound symbol and the exclamation point, which often is called shebang. Why would we call it shebang? Well, the exclamation point is also called bang. I don't know where the sh part comes from, but anyway, I guess it just sounds cool. So shebang. And then we'll want to designate what shell it is that is going to be used to interpret this command, because what's going to happen is when we try to execute a script, if it begins with these two characters, if the file is a text file, it begins with these characters, it will then look at the content that follows to determine exactly what shell to run. It'll start an instance of that shell, and then it will start executing the commands that are in the script. That's the way it works. So we'll indicate that this is a bash shell script this way. So for all the bash scripting that we do in this class, the first line will always be this. You don't have any characters before the shebang and no space between the shebang and the shell that you want to run to interpret it. The other thing to note there, of course, is that for the shell, you want to go ahead and give an absolute address. So that means you start with the slash indicating root. So it's from root, the bin subdirectory, and within that, the file called bash will be the shell that will be executed. So this is the normal way to do it. A couple things to note. If it isn't on the first line and is not also followed by the exclamation point, okay, in other words, if it's on the first line and it's a pound and an exclamation point, a shebang, then it has a particular meaning. Otherwise, if it starts with a pound, that's called a comment. So I can say this is this is my first script. How about comments don't do anything in terms of execution. They're there for human readers of the script to know what the script is doing. And as our scripts become somewhat sophisticated, we won't have a silly comment like that, but we might end up using the pound sign to say, here's a script that does these various things. It takes certain things as inputs. The output looks like this, whatever we need to explain to a human user what this script is doing. Now then, let's just put a command in here, it really doesn't matter what command it is right now. We'll just do something very simple that we already know, something like ls-l, so long form version of the list. And then let's add another command too, and we'll say how about just ps, so we can see the processes that are running. Okay, so two commands on two separate lines. It is possible to put commands on the same line, and the way we would do that is simply separate them with a semicolon. I'll show you that in a moment. But all we're doing is combining a couple of commands that we've already seen. Now this is a very basic way to use a script. We'll do more interesting things a little bit later. Okay, so why don't I go ahead and write that file out, and I'll exit. And you would think we could just run this script. In fact, I'll type first script.sh, and what do we get? Command not found. Why is it not found? Well, remember our path variable. Does the path variable contain this directory? That is my home directory /scripts. Well, of course it does not, because we might have added some other things there prior, but we haven't done it now. So there are a couple of ways that we could do this to fix this. The first is that we could just give a relative address for where to find first script.sh, okay, and try that. And in fact, that's what we'll do first. And then we'll come back to this. We'll solve it in a little more elegant way, at least for our current session. So I type that, and what do I get? Permission denied. What does that mean? Well, let's take a look at it. If I list the files that are here, I notice that I have read and write privileges. And remember, I told you there was that third one that was either dash or it was X for execute. Okay, so here it is. For others, it's a dash. For people in the group, it's a dash. And for the user that owns it, it's a dash. Okay, that means we do not have execute privileges. We're trying to execute a script. And that means to run it in order to get it to do something. And so we need to change the permissions on this file. Our default permissions are not going to work. So there are several ways that we could do that. But this would work reasonably well. We could say chmod 760. Okay. Oops. I probably should tell it on what, right? So first script.shell. And then if we take a look. Okay, so now if we take a look, we'll see that we now have execute privileges. We left the read-write privileges for the group, and I just removed all privileges for any other users. There are other ways, of course, that we could do that. Let me just change it back to what it was before, and let's see, what was it before? It was read-write permissions. You know what that is, right? That's a 6. And then a 6, and then read permissions. Remember what that is? What is that, a 4? And let's go back there. And we take a look at it again. Okay, so that's where it was. We could also, of course, remember, do it this way. Chmod, the user, we want to add execute privileges. Okay, and for that file. And again, you'll see that that gives us execute privileges there. So now that we have execute privileges, we could probably just run that. And you'll see that we get our output. Remember, we had put two commands in there. One was ls-l, which shows us this, and then the other command was ps, which shows us these things. And now you see there's a process that's assigned to first script.sh, right? That's the command that was entered. We know that it's a bash shell that's actually executing that script, but there's a process now associated with that during the time that the PS is run. And of course, now that process no longer exists because it's finished running and doing everything that it said. It got to the end of the file. There was no other commands to execute. So that's it. So you see that it's gone now. Okay, so it ran, it had its little lifetime, and now it's finished. So generally then, if you're in the directory that you want to be in, it's dot. That means current directory / and now I can put the name in. But if you don't want to go to the hassle of that, then change the path. Remember, we could change the path permanently by going into those configuration files, but I'll just change it for the current session. And remember, the way that we can do that is we say path equals. You want to be really careful here. Make sure that it includes everything that was already in the path. Otherwise, other commands won't work, right? So let's include everything that was in the path, and colon, and now we could do a couple things. We could include tilde/scripts, or /home/Perry/scripts in my case, or we could just do this, include dot, and that means whatever the current directory is, search the current directory. Okay, so if I do that, and let's just take a look. Now what we have, now then there's this additional area to search after all the others. If you don't find it there, then look in the current directory to see if there's something of that name. So now that I have that, I can just do this. First script.sh. I really should use shorter names since I'm such a terrible typist, right? And now then you see I've executed that script again with just by typing the command without having to specify a directory path for it. So that'll work for the current session. If I close this and start a new terminal later, I would have to either do that again or else qualify the path for the name of this, right? because this has now become temporary, as we discussed when we were dealing with environment variables last week. Okay, so that's a beginning for our first script. I am going to change it since I'm having such a hard time typing today. I will move first script.shell to fs.sh. How's that? Okay, so now then it has a name that will be harder for me to mistype and make an idiot of myself, right? Okay, so why don't we take a look at some other things that we can do with this really basic script. And one of the things, there are a couple of commands that that were kind of added on in this chapter 11 in the text, which we might as well learn something about because they'll help us to do some slightly more interesting things. There is a command called date, which gives the current date. How's that? Okay. And there's another command called who, which tells you who's logged into the system right now. Now, probably you're the only one logged into your system right now, kind of like my situation here. There's only one user. It's user Perry, who is currently logged in to my system. Probably be similar for you, but if you remember the file sharing exercise from last week, certainly in that case you might have had, if you simply switched users rather than logging a user out, then you would have had two users logged in at once, right? So anyway, a couple commands there. So why don't we go back to our first shell here, and we can use some of these commands, and we'll combine it with echo. So how about this? We'll say echo the date, oops, command, and oops, let's say date, okay, and then we'll echo the who, oops, command, and type who right here. And so now we're seeing a little bit that we can start to build up scripts, fs.sh, with output of our own, or with some text indicating what something is, and then possibly a command right there as well. So the date command, the who command. If I go back in here, what if we wanted the date to be on the same line? You can use the echo dash with the dash in option, and that means that it will not insert a new line character at the end. That way that information will just continue on the same line. So if I do that and run this again, notice now here the output for that echo, it doesn't go to a new line like it did before, and the information's just there. You say, oh, that looks kind of rubbish though. I really want a space after that colon right there. How do I do that? Well, if you want to do that, the echo command, you can add as many spaces as you want after this. It would just ignore them because these are parameters to the echo command. But the way that you could force a space there is to put the thing within quotes, either single quotes or double quotes, but you have to use the same one. So there's the double quote version. I could change it to the single quote version. I'll do it just for interest's sake here. And now I'm forcing a space after that because basically everything within those quotes, you can even see how the editor highlighted that because it recognizes that's just kind of like one thing. And we call that one thing a string. That is to say, it's just a strung together bunch of characters. Okay, but the main thing is it's between either single quotes, as in this case, or double quotes, as I showed you a minute ago, and that becomes kind of one thing. So now we're telling the echo command, echo the following stuff. Don't stick a new line character at the end. In other words, let the output continue on this line after you're done running. And here's the one parameter. It's this one string now, as opposed to before where it was actually three separate strings that didn't have any quotes designating them, right? Okay, so what that does for us then is allows us, frankly, to format the way that we wanted. So there it is. Now that's properly formatted with a space where I wanted it. One more thing to note, they note this in the text, I think it's a really good idea, is that sometimes you might want to say something like this. Let's see who's online. Okay. Now, you can immediately see a problem here because that single quote right there is interpreted as the beginning of a string, and the other single quote is interpreted as the end of a string. So this is going to kind of give us some slightly goofy results, and let's see what it looks like. If I were to just run it like that, you see our let's see who's online. I don't get the quotes anymore. So it worked, okay, but I lost those characters. So I say, well, wait, I wanted those characters in there. Well, of course you did. So how are you going to do that? You want to surround those things with quotes so that you make them a string. But the quotes have to be the opposite quotes of the ones that are inside there. So I'll use the double quote on the outside to make one string. And again, you see that the Nano editor figured that out and was able to highlight the string for me. So it's good. It's one of the benefits to giving something the shell extension. Notice we call this syntax highlighting, where keywords are blue here. These options are in a kind of green color. Strings are yellow. And look, I've got this kind of, I don't know, strange kind of tealish blue for lines that look like comments, or else the first line. And anyway, let's run it. So you see now I have those characters included as I'd intended. So now we're going to make use of some of our environment variables to do a little bit more with scripting. You will recall, for example, that we have various environment variables like this one. We can echo home. That has a certain value to it, right? Let's use that in a shell script. What we'll do is we'll say nano. This time I'm not going to use the .sh extension. That's really for human beings to tell them, hey, this is a shell script. But the system really doesn't care what extensions they have. So it's not like Windows where for something to be executable, it has to have a certain extension like .exe or .bat or something like that. Okay, so anyway, I can go in here and shebang /bin/bash, and then let's echo something like $user, and we'll do another one, echo $uid, echo $home, and echo the path as well. Okay, so there's a few of the variables that we looked at before. You'll notice, by the way, there's no syntax highlighting here. That is to say, everything's all in one color. And remember, we were noticing before that Nano's kind of smart about doing things, but it only checks to see what kind of file it is by examining the content when you first open it. And so when we first opened it, the file didn't exist. It has no idea what kind of content it is. But as you'll see, we write it out and exit. And by the way, at that point, you notice that we did get the syntax highlighting, but now it's there. See, so we've got different colors for different things, which is handy because you know how the editor is interpreting it, and it can really help you see a lot of errors. But now, what else do we need to do? If we take a look at this, whoops, -L, we'll notice that we do not have execute permissions on S2. So let's add those. So we can say chmod 764 S2. That ought to do it, right? And there you see we got the appropriate permissions. This is why you need to memorize those numbers. I could also, of course, as we said before, have just done this, right? That would have done the same thing. In fact, that would have created no change at that point because that permission already exists there. But anyway, it's executable now. And so now if I run S2, I get the values for those variables, environment variables, that are part of the current context. So Perry, user ID is 1000, there's the home directory, and then here is the path. It'd be nice if we had some additional text to tell us what those are, right? So let's see, we'll go back here and let's echo some other stuff. We'll say user info for so-and-so, okay? And we can say user ID colon, and we can say home colon, and we can say path colon, and if I exit from there and we run S2 again, here's what we get. User info for Perry, and it says user ID colon and 1000, home colon and all of that, and then path colon and then all of that. So we've just added some text so it's clear what kind of info we're looking at. Now as I go back in here, a couple things to note. Notice that anytime I'm reading from a variable, there's a $sign before it, as we said last week, right? Well, the shell, as it's interpreting these commands, now remember what's actually happening is we're executing /bin/bash, and then we're giving it everything else in this file to execute. Okay, so it's executing it just like you were typing these things in, except you don't have to type them in because they're stored in a file and they're being executed one after the other. Okay, so it executes this line first, and then it executes this line, and then this line, and then this line, just in sequential order, going down the page. Now, as we continue a little farther with scripting, we'll have things where it doesn't necessarily execute in that exact order. We'll control the order with certain control statements. But for now, we're just executing one after the other. And so, as that happens, then the shell interpreter is executing this echo command with the parameters that follow. And when it comes across something that has a $sign, it knows that that's a variable. So it looks those variables up and then inserts their value in place of, like in this case, $user or $UID. So you saw Perry instead of that. You saw 1000 here, and then /home/Perry instead of $home. And this works whether it's by itself like that on a line, or whether it's even, you could even enclose these within quotes. Now notice I don't get any special highlighting for $user indicating that is a variable anymore. It looks like just part of this string, just a string of characters. But what we'll see is as I exit from here, okay, and type S2, there's no change in the output. That's the point. Okay, there's no change, as you see, in the output for including it in there. So that does create one problem, and let me just show you what that is. And let's exit from there, and we'll make a new file called S3, and you know what this is going to be always, right? I'm using the bash shell, and why don't I echo you owe me $100, okay? And we'll write that out. And let's execute S3. And look how the message changed. Remember, it said you owe me $100. Now it says you owe me 0, 0. That's kind of the opposite of what we were trying to say. So what's going on there? Well, what's happening there is that the command interpreter, it comes across this $sign, and it says, oh, I'm looking for a variable. And then it looks for the variable with the name of 1, and it finds that there is no variable with the name of 1. And so at that point, it inserts no characters in place of the $ and the 1, and then it just continues replacing the other characters. So if you really actually want to print a $sign, then you have to use what's called an escape sequence. You do that by putting a backslash before the $sign, and you'll actually output the $sign. Okay, so let's just see it in action, right? And we run that, and now that's as we would expect. So how is that valuable? Why does it matter? Because I could do something like this. I could say, let's just eliminate this stuff. I could have the intention of saying $user equals, and then I want to actually have the value $user in there. But the first time I wanted to actually say $sign and then user equals, because I'm trying to actually output this exact text right here, right? So how do I do that? Well, put the backslash there on the first one, but not on the second one. And let's just write that and see, and you'll see that you get, in the first case, the actual text $user, and in the second case, it expands it for you.